Hi, this is Mrs. Young, and this is our first lesson in the third part of our three-dimensional unit. I like to call this unit the cross-section and revolving unit. This is day one of this short unit. Hopefully, you should have already watched the intro video that's 3 minutes long, posted in Google Classroom, and checked out the new stamp sheet. Also, you should have printed out the pages from this lesson that I posted, pages 1 through 4. If you do not have a printer, then you can use the electronic version with the Kami extension. So if you have to use the electronic version, make sure that you read the directions or watch my video directions in Kami. But again, I would prefer if you could print the 4 pages and we'll just work directly on those pages. So right now we're watching the lesson 1 video. That's what this is right here. So this is our lesson 1 video. And then tonight your homework will be the pages 3 and 4 that I posted. So I'm going to share my Smart file, one of the pages that you printed for today. And I'll just kind of read over the top with you. We're going to talk about cross sections, which we did talk about once before. A cross section is the face that's formed when you make a slice through an object. We create cross sections every time we cut a slice of cheese from a cheese block. Most of those cross sections are squares if we cut them just right. Another example of cross-section cuts would be the triangles right over there on the right. When we slice the cross-section parallel to the base of that triangular prism, we get copies of the base. So again, our bases are the green triangles, and if we make a cross-section parallel to that, we will still get the same right triangle. A cross-section cannot contain any piece of the original face. Again, a cross-section cannot contain any piece of the original face. It all comes from inside the solid. In this picture, this shape right over here, only the gray piece is the cross-section. As demonstrated by the cross-section of this cube, not all cross-sections need to be parallel to a face. In this activity, we're going to investigate the different types of cross-sections of a cube. So first, we're just going to make some quick predictions. Before beginning this activity, predict which of the following cross-sections are possible for a cube. Place a check mark in the box beside the polygon you feel are possible cross-sections. Clearly, you can cross-section a cube and get a square, or clearly we see that we can do a triangle, but there are 15 different shapes listed here. So I'd like you to pause the video and select which ones you think that you can come up with when you cross-section a cube. Again, we're cross-sectioning a cube. Right now you're just guessing which types of cross-sections you could make. So go ahead and pause the video and make your selections. Okay, so I didn't actually check anything because everyone could have different possible predictions. I don't know what you're guessing or thinking. Like I said, I know I can do a square and a triangle. I'm sure there's other options that I could do. Next, we're going to go to a website called showdoor.org. Showdoor.org, interactivate activities, and we're going to be looking for the cross-section flyer. So this is the website we're going to need to go to. We're going to try to set this to a prism with 4 lateral faces. A cube has 4 lateral faces. And then we're going to be able to look at different cross sections electronically. So this is kind of a cool website. So I'm going to go ahead and change which page I'm sharing with you. Let me go to this one. Sorry, I'm trying to figure out where I'm at. Okay. So if I go to, this is just showdoor.org. I just wanted to show you this website, showdoor.org. And if we go to the activities over here on the right side, right, and if we go to interactivate, so I'm going to go there. There's actually, and I'm going to go to activities. So it's showdoor.org, interactivate, activities. There's a lot of different activities here. Some of them are a little bit more advanced for us. Some of them are more calculus based, but there's some very cool activities that we'll be looking at. This one and then another one we'll look at in this unit. So you might want to consider bookmarking this page. So just a thought, you might want to bookmark it because we are going to come back to some of these activities. But right now today, we're going to be doing the cross-section flyer, Or maybe you just want to bookmark that page, cross-section flyer. So this will give us a visual of what a cross-section looks like on different three-dimensional shapes. It defaults to a double cone. We're not going to use double cones at all. Cone, we're not going to use cones right now. Cylinder, we're not going to use a cylinder right now. Pyramid, we're not using that's actually a pentagonal pyramid, but we want to go to prism. So make sure that you select prism. When it says show foci and show coordinates, the foci is if you're using like the cone or the cylinder. Showing coordinates, like if I selected that, again, it's showing me different coordinates. I do not need that. So I'm going to say do not select either one of those. Down here at the bottom, center axis on points near the origin. Again, that's going to be the default. Leave it like that. Your grid, you can see over here on the right, this is the grid of the cross section. You could go no grid. You can go dark grids. I prefer the light grids that it defaults to. Down at the bottom, you can change the color of the cross section. So it defaults to red, but I know like my son is colorblind, so he has a hard time seeing red or green. He probably would pick blue or purple or brown. Again, you can pick whatever color you want represented for the cross section. So that's just a personal preference. Also, this cross section right here, this is a cross section of, this is a pentagonal prism, and the cross section is a 5 sides, it's a pentagon. So if you have a hard time realizing what kind of shape that is, you can actually click this and it'll tell you like, oh yeah, your cross section is a pentagon, right? So you can click that on or off if you want. I just usually leave it off. But down here, I'm going to go all the way down to where it says lateral faces. Right now, a pentagonal prism has 5 lateral faces, those 5 rectangles around the middle. We want it to be 4. You can increase it. You can go all the way up to a dodecagonal prism, right? But we want to go to something that has 4 lateral faces. There's 5, there's 4. So that'll give us our cube. So again, make sure that this is set to 4 lateral faces. So you have your cube shape. Also, kind of cool, you can go ahead and click on the cube shape and move it around and look at it from different angles or perspectives, excuse me. When you're done looking at it, you can reset your view. So again, I have a mouse. I'm left clicking on my mouse and then just kind of moving it around. On your Chromebook, you would push on your little pad, you would push on the left side and then just kind of move your finger around on the touchpad. So you can kind of look at it from different angles or perspectives and then reset it back to the original. And then now what you're going to do is you're going to be moving around these levers, sliders, to see the cross section as it moves and changes. So you can rotate your slice around the Y, or you can rotate your slice around the Z, or you can actually move the slice up and down. Keep it set to 4 lateral faces and go ahead and play with those rotator or sliders. You could even animate them. I'm not going to do it for you, but it's super cool, super fun. I don't want to spoil the surprise, but go ahead and try to animate and just watch it go through the different cross sections. So what you're going to be doing right now, I'm going to have to go back and share my smart screen. New share. I'm going to go back to my, where's my smartboard? Okay, there we go. I'm going to share my smart file. And I'm going to go ahead, and it says here, create as many polygon cross sections as you can. So using that Shodor website and playing around with the sliders, you're going to check it out and see all the different types of cross sections you could get. Again, a cross section on the right is the 2D cross section that you have created from the 3D shape. So on the second page of your notes, this is where you're going to record the actual cross sections that you're coming up with. So draw and shade the cross section that matches the given polygon. So there are those 1, 3, 6, 9, 12, 15 shapes that they mentioned before that you try to predict which ones you could come up with. So here you're trying to actually draw the cross section that you discover using that website. So this is where you're actually going to pause the video, and this, like if we were in class, I would probably give you a good 10 minutes to work on this. So I do want you to pause the video for a significant amount of time here and go ahead and try to see all the different cross sections that you're able to come up with. And then we're going to come back and share out our results. Okay, so go ahead and pause it. Take a good 10 minutes to draw and shade the possible cross sections that you can find. So pause it. Okay, so here's just one that I drew, and you know that I'm not a very good drawer. But if we slice it straight across, parallel to one of the bases, then obviously we would get a square shape. And then that's what I think it looked like on my page. I'm not sure if it was turned or rotated or not. But of the 15 shapes, how many were you able to come up with? So hopefully, let me go back to my original page. You should have, if you go back and double check, you should have been able to come up with a square, a rectangle, a rhombus, a parallelogram, a trapezoid, an isosceles trapezoid, equilateral triangle, scalene triangle, isosceles triangle, right triangle, pentagon, and hexagon. You should not have been able to come up with a circle, an octagon, or a decagon. I'll just tell you right now that a cube, we know that a cube has 6 faces, right? The 2 bases and then the 4 lateral faces. So 6 faces, like 6 sides on a dice. So the hexagon is actually the biggest number of sides in a cross section you can have. So you can't get an octagon or a decagon. And obviously a circle has curved sides, which you cannot get curved sides from one of our prisms. So again, the biggest number of sides in a cross section for a cube would be 6 sides, which is a hexagon. If instead of a cube, let's say that we used a pentagonal prism, which had 5, 6, 7 sides, right? So then you could get a heptagon. So again, the number of faces will determine the largest type of cross section you can come up with. Hopefully that makes sense. We'll talk more about it. So I'm going to share out some of the pictures or results that they shared with me. Again, we had the square. Hopefully you had a rectangle, definitely a rhombus, a parallelogram, yes, a trapezoid, an isosceles trapezoid. Remember, that's a trapezoid where 2 sides are congruent. An equilateral triangle, yes. A scalene triangle, yes. Isosceles triangle, yes. Right triangle, yes. Pentagon, I feel like they have a bad example because it went off the screen, but definitely a pentagon, yes. And a hexagon, yes. So those are the 12 of the 15 that you could come up with. So again, I'm hoping you took your time to actually play around with that cross-section tool. It's a very cool little website there. Your homework tonight is going to be the next 2 pages, and I apologize that it didn't say homework on the page, but it's page 3 and then page 4. And you can see that some of these, they want you to actually draw in the cross section, but also make sure that you label it. Oops, sorry. Make sure that you label your cross section. I don't know why I scrolled that out. You want to label your cross section, like with tick marks or right angle marks. So make sure it's labeled. And also make sure you explain to me why it is the shape it is. Like, how do I know that's a rectangle? What's important about it? What are some properties that we know about that shape, right? So there's 2 pages there. Page 3 and page 4 is your homework for tonight. But again, go back and play around with that website a little bit as well. And again, if you have any questions, just reach out to me, email, Google Classroom. Bye, guys.